Welcome. Today we look at the PLC, programmable logic controllers. Now these PLCs, I also have, I'm going to be looking at programming here. Mostly I'm going to be looking at the ladder programming for starters. Now, okay, I'll throw in statement list. I want to be flexible as I do this so that people can see, can learn a lot more. What I'll do is I'll look at basic programs. I'll start with basic programs. I don't want to make our videos too long, so I'll rather do a lot of basic programs so that you can understand the complex. Because obviously, a big program is just a compilation of these smaller programs put together, right? Just like a major electronic circuit will usually be small circuits that are actually assimilated and made to work together. So now also our big programs are actually having smaller programs within, right, that assist with the understanding now. So I'll basically dissect and try to go with the smaller programs so that when you have a bigger challenge, it is easy for us. So let's start with understanding basic functions like stop, start, latch, So let's rather do that. Let's look at, so which PLC are we going to use? I have an option to look at a few. So what I'll do is I will take it's getting more and more popular, especially in training centers. So I will take the Delta PLC. Now, Delta PLC will normally use PLSoft or WPLSoft. All right, so I've started them with the WPLSoft. Let's try and do basic programs. So once you open, you notice there is a video that I made that shows you the installation. All right, so you can go and look at that to understand how the installation works. But now what I have now is I have opened. I've clicked on the shortcut to open this software. So now if I want to start on a new program, I've got a few options. I can go to File. Under File, I can click New. Then I'll obviously have a new platform to work on. Or instead of, if I don't want to do that, I can simply come. There's an icon there that says New. All right. So I could click on that. If I click on that, it's going to take me where I'm going to use the final option. The final option is to hit, as you can see there, it shows you hit the Control and the N. If I say Control N, you can see now this what any of those other options would have taken you to this space here. All right. The first space there is basically for you to give a title. All right. What am I going to do? I'm going to do basics. All right. So my files are going to be called basics, but within the basics, there's going to be different aspects that I'm going to be looking at. So now I'm going to look at, for instance, I want to look at understanding start in here. So what I'll call it start. Start. All right. So then I'll come and say on the name here, I'll say this is what? Basic. All right. Basic understanding. All right. I'll say basic understanding. All right. But then now I'm specifically looking at the start. So now I'll come and say, there are different models, just like with the cars. We've got different models. We've got your BMWs, for instance, having the X whatever, X3, X5, whatever. So we also have different models with with the PLC. So you ought to choose the one that you have. All right. So I'll go and say, all right, the one I have is the SS2. Let me confirm. Yes, that's an SS2. So I'll come there and say I have an SS2. All right, now I knew I have an SS2. The only reason I looked is I'm reminding you that you must check your PLC and make sure that you've got you've chosen the correct one. Now let's go and see. All right, the COM port is basically your communications port, where you're going to when you plug in your physical PLC, that is how it's going to that is the port that is going to this software is going to interact with that's going to use to interact with the physical PLC. All right, so I'll leave that there. I don't know. I've given a file name, so next time I look for this file, I know I'll have to look at basic understanding. But it will, if I say okay, now you will see what happens. You see that it says there basic understanding and it says start there, meaning that I can have another basic understanding, but then I'll make people understand how to stop, for instance. All right, I can go on basic understanding and then I'll make people understand how to latch. That's exactly what I'm going to do. So now all I want people to understand is to start. So with start, normally to start anything, you need to energize it. All right. So what we need what is called contacts in PLCs. In the hardware spaces, we would actually use switches. Here we use a switch has a contact, because where you wire onto a switch, where you wire your power in and your power out on a switch, those are contacts. All right. So we use the language of contacts here with PLCs. So I'm going to put a contact where I'm going to wire my start switch. All right. So I'm going to use that contact. We've got different contacts, as you can see. If you go through that list there, you can see we've got contacts. We've got a normally open contact there. We've got a normally closed contact there. All right. We've got a rising edge trigger switch there. All those are contacts. All right. So now let's start with the basic contact, which is that they're normally open. Now I've done that. You see how I get here by doing that. I can also go and say, if you look there, it's written F1 there. So if I hit F1, if I come to function and I hit F1, you see it takes me to the same to the same page. All right. There's a third option. I can simply load. Okay, I can simply load that contact there, that space there. I load LD. I load with what? Now, if I do this, if I say load, you will notice that previously we were here. This one take us straight here. If I use a statement and instruction, it does not really give me this box. I could just write out whatever I want right there. So I could say, when I say load, now I name the contact that I want to place there, and let me show you something else before I do that. I think this is going to be a little tricky. Let me show you something else before I do this. Let me go back to the simple option of clicking there. If I click there, you can see that dialog box is open there. What does it say? It says I clicked on a normal open contact, and I could then choose what it's supposed to be. I could choose that is an input. Our inputs for the PLCs are the X's. These are the physical inputs that you can wire to. But we also have what we call relay contacts, right? So the rest of them are relay contacts, meaning that if a relay is to energize, some of these contacts are going to obviously be either activated or deactivated, depending on whether they were normally open or normally closed. I don't want to get too technical, because remember, we're starting here. We're going to understand this more when you see look at our other videos where we what. I prefer we go through the programming before you can go to the physical PLC, because then looking at the PLC at this stage might not make sense. But at a later stage, you'll understand what we mean by internal contacts, and this is an input. This is a wireable contact. I can wire to this contact. I don't want to use the language of I can wire to it. Yeah, but basically I can wire to it. It is the physical input on the. If I look at the PLC, when I show you the PLCs at a later stage, I'm going to show you the PLCs. When you look at the PLC, you will see that you can look at it and see the inputs. You can physically look at the PLC and see the inputs and the outputs. Probably I can use this as an example. I'm worried about the little picture we have there. It might not be clear. I don't think it's going to be clear. That's why I didn't think really I must bother. I must bother. I will show you when I show you the physical PLC with a better camera. Now, for now, suffice to say, this is a physical input, and our inputs are called X's for the PLC. So as you can see, I have between X0 up to X377. That is 378 inputs. That is the range. I've got 378 inputs, right? So I can choose any one there. Can I? Not really. I wouldn't do that. Because on the PLC itself, if I take an example of the PLC that I have here, this one here, for instance, has inputs X0 up to X7. So if I'm going to use that PLC, I cannot have X8. So you see now, it has to be, this is going to be determined by your physical PLC that you have. That's why it's also correct to choose the proper PLC model. All right, so that you do not have, you end up probably wiring inputs that don't exist for that motor process. All right, so for instance, this one ends at X7. If I wire X8, it means I won't be using that PLC. It does not have an X8. So what we then do is, we know our input has got inputs X0 up to X7, so I can use any one of those. unless some are dedicated to specific things. But if there's no dedication, let's assume now there's nothing dedicated to anything. It's an open scenario. So now I'll choose X0. So X0 is mine. So I'll comment there and say, what am I using this for? Let's just call it a switch for on and off. I'll just call it switch for on and off. All right. So let's just say, what does it mean? This is a contact on the PLC to which I'll wire my switch. All right. So now I'll go and say, okay, but I want my switch to run something. What do I want my switch to run? But then with the PLC, remember, PLC is soft wiring. So this is the program. It's soft wiring. It is wired only by the program. It is not hard wiring, which is the physical wires. All right. So, but that X0 on the PLC will have to be physically wired. All right. But we'll come back to that later. For now, let's say our switch will simply start something and stop it. All right. So let's go and say X0 will activate an output. Our outputs are the coils. If you come and look there, you see coils there. All right. So this is an output coil. All right. So you can come there. Either you click there, okay, and you see there you have an option. You've got physical outputs that you can wire to on the PLC, which is for this Delta PLC, which is the Ys. But there's something that you call internal. Meaning that it's not a physical output. You can't wire to it. It's only in the program. All right. So now I want a physical output. I want to be able to say on, and then something responds. So I'm going to say I want a physical output. So I'm going to call it Y. Again, with the Y, I've got Y0 to Y377. But remember, again, I'm limited by the PLC I have. If I look at the one I have here, the DWPLS02, the Delta WPLS02, I'm limited to Y0 up to Y5, which is only 6 outputs. So I cannot use Y beyond that. I cannot use a Y beyond Y5. So I'll come in there and then I'll say I'll choose the first one, which is Y0. All right. Notice how I could have opted. You can see now. Or let's actually expand this. Let's maximize this so that you can see our entire field. So now I could have opted now to say what I do, or I put a comment. All right. I could have opted to say this would have been Y1, Y2, Y3, up to Y5 because I'm limited by those 6 outputs for this specific DWP PS02. All right. So now what does it mean? It means now this is a contact. If I wire to this switch, if I energize that contact, if those contacts are energized, this one here must then respond, all right, by getting energized as well. Let's see that. How do you see this? With PLCs, we speak the language of simulation. We program, then before we can take our programs and put them in physical PLCs, we first test them to see if they don't have what, we debug them, we check them for errors, then we see that our programs actually work fine, all right? So we'll go there and you say, all right, is there any problem with the what? With the PLC? If there is a problem, you will actually get an error code, all right? But then now we go there and you say, okay, let's look at this. Let's go and say, simulate this. Check if there's a problem with the PLC. I don't get an error message, so it says there, fine. If there was an error, it was going to tell me that no, your program something's wrong, all right? So now I've debugged my program. There's the debug, there's the C, it's checking, all right? So I've debugged my program, I'm happy. So I come in and say, all right, fine, I'm on simulator mode, and I come in and say, let me put it online. All right, oh, I hit the wrong one. I hit the wrong one. Let's go back. I want to go back to this mode. All right, I want to put my PLC. Something is missing here. I put it on thing. I don't see. There's one window I don't see here. Let me see view. I don't see what's missing here. All right, something is missing. I don't see my. Oh, is it because? Yeah. I'm on debug. All right, let's get out of this one. Yeah, I was on debug. So now I wanted to put. I did not come out of debug, so that was why my other tools were not available. All right. So now what I wanted there. I'm on what? I'm on simulator mode. Now I come in and say, when I was debugging there, I could have run what I would do to debugging. I could run this check there, run this. It will check. So you tell it how many cycles it must check for, right? How many times it must run for. So run it once, you can run it 5 times if you want, just to check if there's problems. This is what debug mode is. I didn't finish on the debug mode, but I don't want to get all the technical. I want to dwell a little more on the programming rather than on the what. On the rest of the controls, which we'll learn as we go. So now on the debug there, because I was on the debug, I forgot to come out. So this I'm done debugging. So I come in and say, okay, now let's put this online. We didn't detect any errors. So you can see now it shows you it is what? It is online. All right. You can see that it says I'm on simulator there. And then now you come and you say run, because now I'm on simulator mode. I put it online. Now I say, let me run. It will ask me if I want to compile it. I will say, do I wish to run the PLC? Yes, I want to do that. So now it's on run mode. You can see now it was on stop mode. Now it's on run mode. All right. So now because it's on run mode, I can then test my PLC. Now what I'll then do is I come to my switch, the contact of my switch. I activate it. How would this work in real life? In real life, I would have had to actually energize the input X1, right? If I energize the input X1 with a proper input, remember some inputs can be 115 volts, some inputs can be DC 24 volts, some inputs can be 230 volts. So you have to check what your input voltages are supposed to be, right? And now what I'll then do is, if I energize that, and some of them are already pre-wired for you and already digital inputs. All you have to do is close switches, close and open and close switches, right? So now I'll come then and say, okay, let's energize. Energizing this switch is as good as on the program here. It's as good as setting it on. So when I set on, you can see it goes green. There says it's on. But look at the output that I didn't touch. I didn't touch the output, but because I energized the input, that run is now completely closed, and therefore your output is also energized. I don't know if, because it's, the initial steps are a little bit difficult, like the law of inertia, when something, the law of stubbornness, when something has not been moving and now you try to move it, that's a hell of a thing. It's a hell of a job. But then when it's moving already, it's easier to keep that motion. It's actually tougher now to stop it. When something is in motion, it's actually tougher to stop it. That is the law of inertia. And so we are starting on this. So we are a little bit inert. We are a little bit stubborn. Our minds are a little bit stubborn. As we go, you will see how we get now more comfortable with the movement rather than the stopping. All right. So let's suppose now, let's go back and look at this. We say, okay, this is the switch. If we energize it by setting it on, it went green and the output follows suit. Now I'm going to set off. When I set off, you see there, so it's like you operating a switch. This is like you operating a switch. All right. So this is okay with toggle switches. A switch that you can just put on, let the job happen. Remember, Y0 can be anything. That could be a machine, that could be whatever. All right. So it depends on what you wire on that output. All right. It could be a light. Whatever you wire to that output would have been energized when Y0 went green there, all right? So what it is, what our simulation tells us here, our simple toggle switch is working perfectly. Let's toggle it on, and our machine goes on. Our Y0 is energized, as you can see. Let's toggle it off. So with the toggle switch, this would be perfect, all right? So this is the basic understanding of the stop, start with the what? With the simple toggle type operation. All right, I want to end it here. Remember to like. If you want more, remember algorithm, how these videos work online. Algorithm helps you make things easy to get. Helps the work to be easily accessible. So if you can assist with either commenting, it's easy. Just tell us where you are so that we can at least have feedback of who we are talking to. It's nice to know that I'm talking to a kid in Joburg. It's nice to know I'm talking to a kid in Cape Town. It's nice to know I'm talking to a kid in, I don't know, out of the country for that matter. It's nice to know I could be talking to someone in Europe. So on the comment section there, you can tell us where you are so that we can at least see to gauge our audience, the size of our audience. It would appreciate that very much. Otherwise, you can also just what? Like the video, would appreciate that as well. So that was your start. That was your simple start stop of, let's say, specifically for a toggle type situation, right? Where your switch is a toggle type. You put it on, it stays on. Put it off, stays off. Machine goes on and off like your switch. You just go to your house. You put on, you press the switch, you depress the switch, light goes on. You depress the other way, and light goes off. So this would be a simple scenario like that. I hope this was easy. I hope it was a nice introduction. I understand that starting off things can get a little bit confusing, but let's meet again when we operate. We are going to work with press and release switches. All right. So this, I would say, it was the basic understanding of a basic toggle. I think I must rename this to what? To toggle type start. All right. Toggle type start. All right. Remember to like, and I hope you are subscribed already. If not, just join our crew so that we can work together and try to make this as easy as we can. All right. Cheerio. Ciao.